Hey everyone, welcome back to another class in Python. So this is the class 9th brought to you by IOSD UIET KUK, and this class is going to focus on sets in Python. And I have got a doubt from Ritik in the comment section. The doubt is related to the searching and basically searching and slicing in list. So we will be discussing that in this video only. Now sets are not so important in Python, but yeah, we have a few operations on sets as we are going to discuss them in today's video, like union, difference, etc. Now, so sets are basically mutable objects, very similar to list, but there is a special kind of set known as frozen set, which are actually immutable. So according to the definition, a set is an unordered collection data type that is iterable, mutable, and has no duplicate elements. So basically a set cannot have a duplicate element. So this is what makes it different from tuples or list. So Python set class represents mathematical notion of a set, and hence we follow the mathematical Venn diagrams and set operations like set A, complement of set, disjoint sets, proper sets, intersection of sets, and union of sets, etc. We also have a difference of set. I probably don't have an image here, so let me just show you. Okay, yep, like this. So this is a very good image here. Let me just add it. I'm sorry. So this image is taken from online mathslearning.com, and then you can just go to this image right here. Okay, and this image is from Ask IITN. Okay, so let me add that link also. Okay. Done. So the first image is from online maths learning and second is from Ask IITN. So it's really simple to understand: union of A and B, intersection of A and B, difference A minus B and B minus A. Then there are some other operations like subset, disjoint sets, etc. So we will be discussing that in a minute. Again, references are taken from Geeks for Geeks. The major advantage of using a set as opposed to a list is that it has a highly optimized method for checking whether a specific element is contained in the set or not. Basically, we are talking about searching here. So it may be possible that multiple or duplicate objects are present in the list. So it's actually good to form a set when you are trying to get the unique codes or unique elements inside a list. So basically, set is a list with unique elements. Okay, so this is the Geeks for Geeks page which we are going to use as the reference, and it's written by Jay Patel. So thanks to him for this reference, and you can check the recommended post as I told you in the last video. Okay, so let's start with the formation of a set. So basically how you form a set, so you have to write it like this, like set 1. You can simply write it like 1, 2, 3, and so on. So this is a set. So if you print the type of set, print type, it may print dictionary also. Let's see what it prints. Yeah, it prints set only. So this is kind of set. And another way is to write like this. If you want to convert a list into set, you just write it like this. So you write print, set 2 is equal to, let's create a set 2, set, you do it like this or this, and square brackets now, 1, 2, 3, 4. So if you note here that set 1 is a subset of set 2. Okay. and if you just print the type of set2, let's make it smallest. Oh, I'm sorry, type class set. Okay, so this is again typecasting, example of typecasting of conversion of this list into set. So it's really simple to convert into set. Just write set and it's done. Now you can see that the set1, that is 1 2 3, is contained in the set2, where set2 is basically A and set1 is basically B. So it's 1 2 3 and it's 1 2 3 4. So set2 is set1 is the subset of set2, or set2 is the superset of set1. Okay, moving ahead, you can see a frozen set, and you also have a operation here like set2. Like these are the operations in the set here. So you can add a number, like let's add an element to a set. It has no effect on the element that is already present. So this is the information told to me by the Google Colab only. So let's add a number like 3, and let's see what happens. And print set again, print set2, not 3, it's repeated. Let's add 5. Okay, so 3 4 1 5 2 is basically 1 2 3 4 5 and so on. Okay, now let's add let's try to clear some, or let's try to, so these functions are not given in the reference. Let's see the other functions here, like clear, or how does it work? Let's see, does it need anything? Function set dot clear, that's all. What if I print set2 now? No effects. Let's try to add something here like 3. Clear takes no arguments, so clear is probably of no use. Okay, what are the some other functions available here? Set2 dot, then pop. Okay, you can use remove or pop only. Set3, and then print set2. It gives no information of how to use this function remove. Let's see it in the end. It's probably not working with set2, the set data type. That's why it's not mentioned in the GitHub. This Geeks for Geeks also. Okay, coming back to the reference only. Now we have some methods, as we were talking about. That's really important in this case. Okay, first is the add or union. Okay, add x method adds the item x to the set if it is not already present, like I told you, dot add. Next is union. Now you can use the union here. Let's try to create a set 3. Sorry for that. Say for example 6, or let's take some characters A, B, C, D and so on. Now a set is basically not a list, so we will not be discussing the heterogeneous or homogeneous data here. It's basically used to perform some mathematical set operations or Venn diagrams only. It's not really that important. So let's try to put it in a, just put it in the set2 only. So set2 is equal to, or let's make another set4. Set4 is equal to set2 dot union, in union set3. Let's try this up. Okay, and print set4. Okay, now set4 is notified. It's capital S, I'm sorry, capital S. Okay, so it gets added. Okay, moving to the next property, this was union. So you can see union in here. So union just add both the elements, and if there is some common element like this, say for example there is some common element, it will be only for one time only, because in set, even if there is some common element, okay, it will be unique in the set itself. Now so suppose if there is some common element, that's the property of union basically. So union basically adds and then subtracts. If there is some common element, it subtracts it one time. Now coming to the next property, which is intersection. So set 5 will be intersection of set 2 and set 3. Intersection is basically the data which is common. Okay, so set 5 is basically set 2 dot intersection set 3. Okay, let's see. I'm sorry, print set 5, print, that's capital set 5. Okay, set, what is it printing? Have we done something wrong? Victims equal to people dot intersection vampires. What's the issue? Is it print? It's just printing set 2 dot intersection. I hope that's okay. Dot intersection vampires dot intersection set 3. And there is some common data like 3. It should print 3 here. Okay, so the issue is resolved here now, and it's printing it's printing the common data, that's 4 in this case. Now there was some issue with 3, so now it's printing 4, which is the common. So that's the intersection. Okay, that's how intersection works basically. Next is difference. Okay, so difference is basically, for example, for set 2 minus set 3, let's see what the difference is. Print, just I'm going to print the difference only. Set 2, set 3 small, set 2 small, set 2 dot difference set 3. It prints 1 to 5. Okay, so oh, I'm really sorry, this is the set 2. I probably have removed some data using that remove command, so I have to run this again and it will now work. I now got it. Let's write 3 here. There was no issue with the 3. I hope you guys remember that I removed the 3, so it worked but it was not printing. So remove is the option to remove or delete some data. Okay, so yep, you see this thing, that's what I'm talking about. Okay, now this is set 2 and this is set 3. So if you subtract set A from set B, so it gives the data which is unique in set 2, that is 1, 2 and 5, because 3 and 4 are common. Okay, so it basically means it subtracts both of them and then it subtracts the intersection, so it's 1 to 5 only. And similarly there is set 3 minus set 2, which is your homework. Now let's try the remove command again. So set 2 dot remove 3 and print set 2. Okay. There's no issue. Let's run it again only. Yeah, so it just removed this. It's giving a issue because I initially removed it and then again I run this same command. So it says that there is no element 3 in here. So you use add to add some data, remove to remove some data. If you want to pop it up, so you get pop option, set to.pop, and built-in function or method. Do I need something? Remove and return or arbitrary set element, raise key error if set is empty. Let's try this. Again, this command is not going to work if I don't run this part because 3 is already removed. Function set pop and print set to. Let's run it again. Or let me just write it here only. Okay. So the pop elements remove this first element or 0th element. Okay. If you again run it, it's going to remove this element. If you add some number here, like suppose 2, I'm sorry, set 2, and if you add here 2, what's the issue? It takes no argument. Okay, so it just removes the first element. Print set 2. Is it printing set 2? Class set. Okay, so it just removed the first element. Now difference is, and then it's clear victim set. It clears the entire set. Okay. However, there are two major pitfalls in Python sets. The set does not maintain elements in a particular order. Issue again. That's why we were talking about the order, and that's why you should use the difference instead of pop, because it's not ordered. It's not always the same order like list or something. So it's important properties. The set does not maintain elements in any particular order. Only instances of immutable type can be added to Python set. Okay. Now there are some operators like key in S, key not in S, S1 is equal to S2. Let's check this code snippet for it. So we are going to just copy it up, and I'm going to explain this code to you. It's actually a good code representation. Okay, let's start from the beginning. So Python program to demonstrate working of sets in Python. So basically he created two empty set. He declared two set. It's not creating, it's declaring. So he declared two sets and added some elements to them. So for I in range 1 to 6, add I. So you already know that this will print a set 1. So let's print here, print set, or just set 1 is plus set 1. And similarly, let's print set 2. Okay, he printed it already. Okay, so it's not required. He printed it right here. Okay, so he added some elements in set 1, he added some elements in set 2, then he used the union. We already have seen that, so it's not required. You can run it as the homework. We already seen intersection. Again, it's not required. Now relation. So this relation is basically, as I explained you, the superset and subset. So if some element, if some set is greater than another set, while it has all the elements, like for example, this set, it has data from 1 to 6 and this has data from 3 to 8. So they are basically sets like this. Neither of them is superset, neither of them is subset. Okay. So displaying relation between set 4 and set 3. Set 4 is a subset of set 3. And checking relation between set 3 and set 4. What's set 3? Okay, we have to do that for the code. So set 1 and set 2 have no relation of being the superset or subset because they have different elements. but set 3 and set 4 may have any relation. We will see that in a minute, but before that let's just print up to set 4 only. Okay, let's just print up to set 3 and set 4. Let's see what set 3 and set 4 is. So union of set 1 and set 2, that set 3 is 1 2 3 4 5 6 7, and set 4 is 3 4 5. So you can see that 3 4 5 is contained in this set only. So set 4 is a subset of set 3, or set 3 is a superset of set 4. Okay, now let's run this part only. This part. It will say set 3 is a superset of set 4, as I told you, and in inverse it will say set 4 is a subset of set 3. Okay, because set 4, the data of set 4 is contained in the data of set 3. Okay, now difference. Now there is difference. What difference is? It takes the unique elements of a set. So set 5 will contain the unique elements of set 3, the first operand. Okay, let's run that. Yep. Now what disjoint is? If two elements have no common element or no common data, if two sets have no common data, it's called a disjoint set. So if let's check if set 4 and set 5 are disjoint or not. So it's a function called as is disjoint, and you just write set 5 in it. So I'm checking if set 4 is joint of set 5. So set 4 and set 5 have nothing in common, and it's very clear. This is 1 2 6 7, this is 3 4 5. Now removing all values of set 5, we are using clear. Again, clear has some issues with Python 2 or Python 3 sometimes, so you can leave that also. And finally this part, applying clear on set 5. Set 5 is equal to, now set 5 is set only because we applied the clear. So I hope this set is very much clear to you. It's really easy to it's really easy to understand. Now let's move to our doubt session quickly. So doubt session here. So doubt was asked from Ritik, and it's really appreciable if you guys ask doubts in the comment section. Okay, doubt on searching in list. Now anyone who has a doubt on searching or list, basically you should understand that list is basically a array. As we have learned in C and C++ and DS algo, basically there are many types of searching, like linear search, then we have binary search, then we have quick search, we have hash search, we have any other kind of search probably. Okay, I'm really sorry, it's quick sort and hash sort. Searching is of two types, linear and binary, for arrays, and we are going to discuss linear search here. Linear search, since you have already got your lessons on the if else statements and the loops, you can design the binary also. So that's a homework. So for everyone who's watching this video, it's a homework to design the binary search. So I'm going to take a or arbitrary list, like list 1 is equal to, okay, let's add some elements, 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8, this kind, and I want to find some element like ELM. So in first case I am going to take an element ELM1, which is in the list, and in second case it's not going to be in the list. Okay, so let's take for example 4 or 5. So we have to find this element 5 in this list using the linear search algorithm. How we will do that? It's very simple. We will be iterating from the first element to the last element and compare each element to this ELEM1. So if you don't know how the linear search or binary search works, you need to clear your doubts on DS algo, which happens to be a very prerequisite for any computer programming language. So binary search is your basically your homework, and you can try it on different list. Maybe later. Windows always have issue. Okay, let's start with it. So for you can take this, or you can just take I for I in length of, okay, in length list 1. If list 1 I equal to lm1, print element 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 plus lm1 plus found at plus the location, that's I plus 1, because according to the user it's going to be I plus 1, as I will be starting from the 0 only. Okay, let's try to run this. Int object is not iterable. Why? Is there some issue? Okay, so there was a minor issue here that I just used plus here, which is actually used for strings, so I just replace it with the comma, and it's now running. Okay, and I have to change this one, which the length list one here gives some issues sometimes. So it's a easy method to store it in another variable and just use it here. Okay, another type is when we get the number to be located from the user only. So list 1, again list 1, let's take the same list only. Okay, so element 1 is what we need to find. Okay, elm1 is equal to input enter number to be entered, sorry, to be searched, and now this element may be present in the your list, or it may not be present in the list. So again rest is the same. So for I in n, just print it and add a else statement, else, or you can just what you can do here is to use the flag method. Flag is equal to 0, and if this happens, flag is equal to plus 1. Okay, now after this iterations have happened over the entire list, just write if flag equal to 0, print element element not found. Okay, so this flag element is added, and also you can print like this, print element in this, not in this case, else. So you now separate it with comma, elm1 is repeated, comma, flag times. Okay, let me just add some numbers here which are repeated also, like 6, 6, 6 and so on. So 6 is repeated 4 times, and flag is basically what helps us to determine if some element is found or not, and how many times it has occurred in the entire list. So let's run this. So initially we are going to find some element which is not present, like 9. 9 plus 9 9. Okay, so element not found, and now we are going to run some element which is repeated multiple times, like 6. Element not found. Why? To so I'm very sorry, I had made a very silly mistake here. Like, I had to add int, otherwise the element 2 will be a string type, because the default method of inputting is string, and it was searching the character 6 instead of the integer 6. So I just recognized this error by printing every type, and I got that this element was string and it should have been integer. Another changes I did is to make this n here. I was using this n, so I was using the n of smaller list because I haven't run that code. Okay, and now I have this fresh code for you guys, in which is running perfectly. So let's try it on an element which is not present, like say 9, and element not found, and element which is being repeated, like 6, and it says element 6 is repeated 4 times. Okay, so this is how we perform searching. And talking about slicing, it's really easy again. Slicing now is a concept which is very big for this video, so I'm going to just explain it in 1D slicing. You have to visit my 4A and 4B lecture if you want to see it again. In this lecture I have already in this doubt I have covered your doubt for iteration over the entire list and then searching. Okay, now slicing is very simple. Just for example, I have to print list 2. So if I want to print some specific element, so I just write its location according to me -1. So for example, if I want to print the 5th element, so I write 4 because it starts from 0. So the 5th element 0, 1, 2, 3, 4, or 1, 2, 3, 4, 5th element is printed. Now if I want to print the list after this element, I write like this, and if I want to print the list before this element, I write it like this, and this is basically slicing. If I want to reverse this list, I write it like this, -1. So this is the last element. Okay, and if I want to reverse this ring, I will write it like all to -1 or -1 to all. This is the incorrect order. Okay. This is the incorrect order, and in reverse order this. Okay, so this prints the correct order, and if you write it like this prints the inverse order. Okay, so that's how you print the inverse list. And you can also access all the elements in the reverse order, like if you write it like -2, then it prints the second element. Now if I want to access 8, this is -1, -2, -3, -4. In reverse it starts from -1, in forward direction it starts from 0. Okay, so -1, -2, -3 and -4. So if I write like -4, it says 8. Okay, so that's all for today, guys. I hope you guys enjoyed the video. All the codes will be available at my Git repository. Links are going to be in the description for every reference. If you have any doubt in this video, and I'm sorry for this error, if you have any doubt in this video or the previous videos, you can just comment it down, and I will be covering it in upcoming sessions. Next video is going to be very important. It's going to cover an important concept of dictionary, and it may have 2 parts. So that's all for today. Thank you for watching, and like the video, share the video with your friends. If you have any doubts, suggestions, just leave a comment, and subscribe to the channel. And that's all for today, guys. Thank you.